Welcome back. Today we are discussing about the exercise 1.3. Question number 1. Prove that root 5 is irrational. We have seen in our last video how we can prove an irrationality of a number. Okay, we are using the method of contradiction. So I am directly moving on to the step. Our question is to prove root 5 is irrational. So we'll use the contradiction method and we'll assume that root 5 is rational. So first step is, let us assume that root 5 is rational. Let us assume that root 5 is rational. Rational number means any number that can be written in the form p by q, where q not equal to 0. So root 5 is equal to p by q, where q not equal to 0, and this p and q will be the simplest form, simplified form. Suppose 10 by 20 is a rational number. This can be written as 1 by 2. So 1 by 2 is also a rational number, but in this case p and q must be the simplified form. Here what we are discussing about is p and q must be the simplified form. So 1 by 2, like the simplified form, it must be the simplified form, not 10 by 20. We can further simplify it. So p and q will be the simplified form such that HCF of p and q will be 1. HCF of p and q will be 1. The highest common factor of p and q will be 1, or p and q are co-prime numbers. P and q are co-prime numbers. Co-prime numbers means those numbers with the highest common factor 1, or another way we can say numbers with the factors 0 and 1. Not 0 and 1, that number and 1. They have only two factors, that number and 1. They are co-prime numbers. So in another way we can say HCF of those two, p and q will be 1. Okay, we are moving on to step. Root 5 equals p by q. Squaring both sides. Squaring both sides we get, squaring both sides we get root 5 square, that is 5, equals p square by q square. 5 equals p square by q square, or 5q square equals p square, or in other way we can write q square equals p square by 5. Q square equals p square by 5. So as per our theorem we know that if any number, if p square is divisible by 5, then p will also be divisible by 5. So as per theorem, if p square is divisible by 5, then p will also be divisible by 5. If p square is divisible by 5, then p will also be divisible by 5. So simple step. Now we are going to give substitution. P equals 5c. Okay, p equals 5c. C can be any integer. I am going to substitute this value of p in our equation. So let this be equation 1 and this be our equation 2, and we have made a substitution p equals 5c and substituting in equation 2 and substituting in equation 2. So q square will be p square by 5, right? Our p is 5c now, then 25c square by 5. Okay, 25c square by 5, that is 5c square. Then c square is what? Q square by 5. C square is Q square by 5. Look at here. Look here. Here 5 is q square is divisible by 5. Then q will also be divisible by 5. Here q square is divisible by 5. Then q will be divisible by 5. Okay, q square is divisible by 5, then q will be divisible by 5. If any number is divisible by some other number like 5, since p and q are co-prime numbers and the highest common factor is only 1, now we got that p and q are divisible by 5 also. That is, our assumption was wrong. As per our assumption, p and q are co-prime numbers. They have only one highest common factor, that is 1. Okay, the highest common factor in those two numbers p and q is only 1. But as per our solution, here we got 5 as a factor of p and q. That means our assumption was wrong. So how we can write that? This is equation 3. So from equation 2 and 3, we conclude that our assumption of root 5 be a rational number is wrong. Therefore, root 5 is an irrational. Therefore, root 5 is an irrational number. Since p and q are co-prime numbers as per our assumption, they should have only one highest common factor. That is, the highest common factor between those two numbers is only 1. But as per this solution, we got another common factor, that is 5. Here also q is divisible by 5 and p is also divisible by 5. That means they are having another common factor, that is 5. So our assumption of root 5 be a rational number was wrong. Therefore, root 5 is an irrational number.